keep forgetting that there's a button now for like that you gotta also click for like going live. I keep forgetting to bloody hit that thing. Anyways, yeah. So today I'm gonna be working on some like tutorial ideas and just like doing some stuff and also showing how to do a couple things. I'm gonna be making an actual dedicated tutorial for like dialogue graph, low level physics, but I figured while on stream I'll go ahead and like also show how I currently have stuff. I also want to say thank you to everybody. So a few people have gave me like feedback on like what they want to do and what they want to see. A lot of low level physics 2D stuff, which is kind of the main thing that I was doing on channel anyway, so that works. GTK Graph Toolkit and RSU, which is a render shader user value tutorials for like shaders and stuff. But yeah, thank you to everybody that gave feedback, and now I know what I need to actually work on. So a few people asked me a couple of things, and I figured I'd show them off real quick before we get into stream. And also, I apologize for stream starting or getting everything set up in a little late. I was feeling really nauseated and sick. I haven't had really good sleep for a couple days. It's been making me feel very sick. I wanted to show off a couple things because one person asked about dialogue, and another person asked about Graph Toolkit. And I actually made my dialogue system with the Graph Toolkit, so showing it off will actually show off both of them. Oh, wrong one. I'm going to actually go into here. I'm going to be showing off a few different projects. So we actually go into our Graph Toolkit real quick. I'm going to demonstrate a couple different things. First, let's actually get, trying to think which one I actually want. Let's actually go to, you know what? No, we'll actually go into the dialogue nodes, and before we'll start here. So this is kind of just a quick overview of how I'm doing certain things with the dialogue system. Do note, I'm going to be changing some bit, improving it during when I actually make tutorials. When I did some of this, not all the API that currently exists for the Graph Toolkit exists back then. So hey, yeah. But if anybody's wondering like how I did it, the Graph Toolkit currently only has like editor nodes. You have to write your own runtime nodes. So what I did was I started off with an interface called runtime node, and basically any type of node that I want to be a runtime, you can basically implement this, and you can actually use it for like creating a dialogue node, a animation node on the graph, or you could do it for like audio node, stuff like that. And like for reference, like if I actually go to, let's go to actual dialogue graph real quick. Yeah, let's actually go to my test dialogue graph. There we go. So like you'll see here, I have like my start node. If I actually go into the code real quick, I'm actually gonna close out of this the other project real quick. I actually go into my actual like editor data. Let me grab the, should be like a actually. Oh yeah, I was rearranging all my nodes. There we go. I'm going to be opening up a couple nodes or like couple files real quick, and then I can actually start showing this off. So just 2 seconds while I grab the nodes and so forth. There should be one more. Okay, yeah. Let's get this going. So basically, for the dialogue system, there's a couple different ways you could do this, and there should be my oh yeah, I've been meaning to actually like put those into their actual classes. I was actually testing out like different node types, not just threw them all inside this one class. I was like, that's not right. Yeah, here it is. So to create an actual like dialogue graph first, using the Graph Toolkit, do note if you're using Unity 6.4 and newer, you don't have to download the package Graph Toolkit. This is actually built in. you can actually just inherit from a graph. And the reason why I have like SF graph space first is I want to have my own like graph base class. That way I can create any type of graph. So if I want to do like a dialogue graph, animation graph, stuff like that, I can actually just inherit from my custom SF graph base. All you got to do is basically have a class that inherits from graph. This is Unity's built-in method. Whenever you have a class go and inherit from graph, that's what allows you to start like creating like the graph assets and actually start using like the graph toolkit. And basically, I create a base SF graph class, and then I have my dialog class that actually inherits from that. You can basically add a custom extension for your dialog file. So if I actually like go in here, when I'll have this file selected down here, you'll see that's .sfgr, so Shatter Fantasy graph. And whenever you create like a constant string of it, you can actually pass it into a attribute called graph. And now Unity will automatically know like, hey, this is a class that's going to be like the asset for like an actual graph type. And whenever you pass in the asset extension, you know that is actually going to be the extension that's created for your graph. And basically, you can just create a menu item and you just say graph database. This is actually Unity's built-in thing. And the prompt in project browser, that's actually what creates, like opens up the, choose a folder or save file. This is specific version for like the graph database. They added a custom version just for it. And it's kind of how you can actually like start making a base class for like a graph system for like dialogue or anything and actually create it. The way I do this is I have a method called process graph nodes. And process graph nodes basically just show this off. I have a custom asset post processor. Whenever you inherit from asset post processor, anytime like the asset is actually like imported into Unity. So like if I actually like go in here and actually like click on it, let's actually see if Unity will actually show the post processor. Yep, it won't. I was gonna see if they did, but sometimes whenever you have an asset, it'll actually mention like what post processors is actually affecting it. But basically you inherit from asset post processor and implement on process all assets. And you make sure that the asset that's being imported is your actual like graph date asset. And basically I just get the extension, and the extension is basically the same thing that I actually put here for constant string. So I can just actually grab this and make sure like, hey, for each asset that's imported during the post processing for inside asset database, if it is a graph, load it. And then once it's loaded, we can actually do stuff. So we can actually like update linked assets. So you can actually like, for example, whenever I actually like, I'm going to just add a new entry to the dialog node. I'm going to just say Thanatos and test. And if you notice, it says graph processing pending. So basically, whenever I hit save, the asset importer will actually like rerun on process all assets. So every time I actually like update the dialog graph, it'll actually update and actually run that method. And what that allows me to do is whenever a dialog graph is actually updated, I can actually process it. And basically you can actually go through. So for example, I have a custom thing called a dialog node processor. And basically what it does like what is called like node traversing. Imagine like your dialog graph here. Like imagine your dialog graph is a tree. And each context node here is a different branch. And like the port is the thing, like the base of tree. So like the start dialog node is like the base of the tree. You go up it, you go to the first branch, and you check to see if this context node is something that you can enter, because you can have branch statements like I can actually add like a branching statement, say like, hey, is this quest state true or false? If it's false, go to a different conversation If it's true, the other one, then start this conversation instead. And basically each branching if statement or like a conditional check allows you to actually create a new like a branch node. And basically the dialog node processor takes in the dialog graph that we're currently like just saved inside Unity's asset, and we actually get the link conversation asset. So I actually have like a scriptable object that is actually created whenever I save this. So like for instance, if I actually like go here, I can actually see like, hey, there's the test Thanatos thing that I just added right here. So you can actually see that it actually updates it. So if I actually do like a new test, I can actually save it here. I'm currently like updating this because as you see, there's a little bug right now where it doesn't clear like the previous state things. I'm still work in progress, but you can see it does actually add a new test. So work in progress. It's not like finished. But when I actually close the graph, it does actually fix the extra stuff. So it only adds temporarily right now, but I still want to fix it. Basically, we'll update the actual dialog conversation and it'll start a node processing. And basically all the node processing does, it grabs every node in the dialog graph. We search for the dialog type node that is start dialog graph, and we know that's where we want to start our branching and for our dialog system. If we actually do have a start dialog node, we use that as the beginning where we start processing the nodes to actual conversation. That was the old way to do it. I don't have to do it that way anymore. Basically, whenever you have a node conversation or a dialog conversation, I check to see if it is a context node converter. This is my custom class. This actually creates a runtime version of the dialog nodes because Unity's Graph Toolkit doesn't have runtime nodes right now. All the Graph Toolkit is currently inside a editor code. So my iContext node converter actually creates runtime nodes based off those editor nodes. That way I don't have to manually like create runtime nodes. Basically, context node converter interface allows me to actually just convert them nodes, and whenever it's imported, we just go through that. So if we actually go through here and actually like process nodes, let's actually go back in here for a second. So process nodes conversation. We basically get the list of nodes as actually like a convert, like the runtimes node, convert it from the editor node, and we just add it to the branch list. And once we're done getting all the nodes in that branch, we just go to next node. And if there is no next node, we know we're done like processing the dialog. It seems complicated. Like I'm gonna do a tutorial to actually like do it in detail. Once people actually like see it, it's gonna be like, oh, that's actually a lot simpler than at first thought. Like at first it may be a little confusing, but once you start understanding the idea of like a node traversal, it is becoming a lot easier. And you notice every runtime node actually has a virtual method called traverse node and process node. So traversing the node, basically traversal is trying to figure out what branch we're currently going to be going down to the dialog. Like I said, checking the dialog conditional statement. It could be a quest state. It could be like, do you have an item in your inventory or something like that. So traversing is basically figuring out which branch of the dialog you're actually running and actually returns that branch. And then processing the node is actually making it play in game. So like if I actually, for example, I'm going to actually get rid of this real quick. I'm going to go here. I'm going to go to Thanatos boy here. I'm going to actually go to him. So we notice I'm going to go to my, let me open up the dialog manager real quick. Game UI dialog. So you notice here, dialog manager also shows what is the current like graph being run. So I'm going to talk to him. You notice that the runtime graph shows all the nodes that were like checked for traversing. And then the branch node is actually the current branch node. Since I only have one branch node in there, they should be the same thing. So yeah. Oh, I just realized I forgot to mark that as like a pause. You can actually have background dialogue. I forgot to actually like mark that as whenever I edit it, I forgot to mark that as should pause graph processing. My bad. All right, now let's try it. Yeah, so you can see down here, this is a test. And oh, I forgot. I actually have a different, that's not actually the conversation I have on him. I actually have a different, I was doing a test conversation. So if I actually go to the one that is currently on him, you'll notice that it's same thing. This is a test, and it says hi player, and then yeah, so forth. So stuff like that. This one should actually be set up. It's still work in progress thing. I got to clean up with a new API. Well, new things that I realized you could do. But basically, process node, you can literally do whatever you want inside process node. For example, you could do comparison towards different values. You could have like a processing for like a conversation node. So like, let's actually go down here. Let's grab this real quick. I was going to say, this is actually where I'm actually processing each node and actually like pausing whenever you're going through a conversation. So like it'll finish a sentence and it'll wait for input and then so forth. But yeah, seems complicated. I'm going to be able to clean it up. I'll make an actual tutorial after I clean it up because it is like a little over-engineered right now just because there was things I didn't know you could do, and I had to do a couple things to get around a couple bugs in Unity, but they already fixed those bugs. So I can actually simplify a lot of this. And I'll actually make a very like simplified version tutorial. That's just something that I'm going to be doing on channel, is actually showing dialog graph. I know another thing someone asked about database systems. Like I said, everything I'm showing off today, I'm going to actually like make a detailed tutorial. But someone asked about like a database, like how you do like a database system. Just show this off. So we have like a database registry, and I have like it allows me to put in like any type of database. We have our dialog database, our stat system database, our loot table database, so like stuff like that. And also like region database, like if you played a Metroidvania game, like, you know, you can have different like regions and so forth. So I can add like what regions are actually like loaded into current build. That way I can do like test regions for the current build, and whenever I want to do like a targeted like testing for different areas. So that's actually not that hard to do a database registry. And again, I'll do an entire dedicated tutorial series. I just want to go over like just give people an idea of what I'm going to be doing on a channel in the future for tutorials. The reason why you might want a database registry in the first place, you want to make sure certain things are actually loaded into memory so you can access them without getting null stuff. Like let's say you have a room system, you want to make sure the room system database is actually loaded first before any code in your game tries to actually access it. And there's actually a very simple way to do that without having to do like on runtime initialization or anything like that. You actually go to your project settings and you go to player. You scroll all the way down. Let's see. I might have actually put this inside my build settings. I actually think I did put it inside my build profile because you can actually do it. Oh no, wait, yeah. I did put it inside, you can actually put it inside here or your build profile. You'll notice that there's an option called preloaded assets. You'll notice my database registry. So you can actually create a scriptable object, shove it into preloaded assets, and before the first scene loads in Unity, it will actually load that scriptable object into your game memory, and it will run the on enable for that scriptable object and set that stuff up. So you can actually have a game before the first scene loads, like whenever a player opens up whatever game you're building, you can have a database registry load first. That way you never have to worry about like race conditions for like null checking or anything like that. And basically all the database registry is, I have a abstract class called SF database. It chooses like I have like a set order, so you can actually say, hey, this database is loaded first. Reason why you might want that is, imagine you have like your loot table database that has like references to item IDs. You want to have your item database loaded first before the loot table is loaded. So you can actually choose like load order, and then you have like methods that run whenever the databases are registered. So and you can each database allows you to add data, so I can add like data, remove data, and by doing it this way I could have multiple types of databases, but I don't have to like code them all. I can just make one base class and do that. And like, for example, reason like on register database, inside the actual register databases thing, there's static helper methods for like getting database. So if you ever need to get a database, like the item database or the dialog database to load in game, you actually just say like, you can just say like database registry dot get databases. And you don't have to worry about null errors. You don't have to worry about like if the scriptable object was loaded into memory first, so it's awake, or on enable and stuff was run, and stuff like that. So that's one of the reasons why this is very, very useful. It makes sure that whatever data you need is loaded before the first scene. And you never have to worry about any issues with it. But I'll be getting into like some of that stuff. And if anybody's wondering, like, you can also you don't have to like go to your player settings. There's actually just a method you can actually run, and you can just add it in there from code. But yeah, yeah. So that's like I said, I'll be going into detail. I'm trying to think. Another thing I'll be showing on the channel. So this the database. That's also like the dialog system graph toolkit. I'll be showing those in detail. So after the graph toolkit and database stuff, I'll also be showing how to write a custom physics thing. Well, I've already started like the videos for that. I'll be teaching people how to actually do a custom multi-threaded physics. For anybody that hasn't seen my project, I have 0 box colliders, 0 rigid bodies. There's 0 ray like a normal ray cats or anything. Everything is actual like physics shapes and physics bodies. So I don't have any on trigger. I don't have any on contact 3D or anything like that. So I'll also be doing tutorials on the channel later to actually teach people that. And I'll also teach people how to create their own custom physics components. Like for example, if we actually go to let's go to the platforms. I have a custom physics component called SF tile map. Oh my god. I can drag the inspector, custom physics component that it's a lot more better performant than like the actual built-in like a Unity tile map. And the reason why I say that is I actually using native like native collections like native lists and so forth. So I'll actually be showing people how to actually create their own custom physics shapes, and also I also have like examples to show like Unity 6.3 API all the way to 6.6. And yes, I do have some Unity 6.6 API examples in some of this code. Also, I'll be showing how to create a custom debug feature. So I actually have it where whenever like runtime mode and stuff is actually playing, or it's also an editor too. If anything is like incorrect about like setup about physics, it'll actually like spit out a message saying, hey, your tile map or capsule or whatever is actually messed up. Also do note the shape components you don't need like a rigid body and a glider. The shape components act as both, so you don't have to put 2 different components. They're basically both components into one, just custom written. But yeah, I'll be showing how to basically create a base class, and I'll be showing how to create like custom your own callbacks. So like this is my actual like interface for iTrigger shape callbacks. I'll be doing tutorials how to actually create them, and also how to do like pre-solve callbacks. So imagine you like one-way platforms. you can actually implement like on pre-solved 2D to actually whenever you are jumping from below, when the player hits a platform, you can actually have it run. It returns a Boolean. You can actually have it where, like, let's say your player is jumping from below on pre-solved 2D in your player component. You can actually say, hey, if the player's like the hit contact normal is making it where the player's hitting from below, let the player pass through. So I'll also show how to do custom physics for like one-way platforms and stuff like that. This is basically like my base class. That is the equivalent to like the thing. Also, do note all the components I'm showing tutorials on, they're all burst compiled. There are some multi-threading in different parts of them. So also be showing off how to create like a custom physics world. One of the tutorials I'm planning on doing is actually showing off how to do like I don't know if anybody's ever seen like the Legend of Zelda game where you can like go as a painting into the wall. Using Physics World, you can actually do that very easily. I'm not kidding, like that. It's actually super easy to do that. And like I said, we'll be using native list. So for anybody that's going to be watching this tutorial, don't worry, I will show you how to not to do memory leaks as much as possible. Because since we're using native list and so forth, we actually there are some areas where we had to manually clean up memory. So it is a little bit more advanced, not too advanced. It's not going to be like the custom. Actually, I'll just open it just so people can enjoy this horror. I'm so sorry for anybody that has not seen something like this. I promise it will not be like, oh, unsafe. These are literally like refresh, like unsafe multi-threaded like tile jobs. And for anybody wondering, like, why is it like how unsafe is it? Oh, we're using pointers. Yeah, so like oh no, I might actually do a tutorial on this. This is actually a custom rule tile that uses entity ID. And no joke, in Unity, we're actually like grabbing the data from a RAM address. Like we're actually grabbing like pointer memory address to do very high performance stuff. Like, oh man, the performance difference was ridiculous. I was super happy with that. I might make a tutorial on that. I don't know. That one might be a little bit like too advanced for starting like areas, because let's see if I can actually find it, because there should be like one. Oh yeah, here it is. Like I'm actually calling into like C and C++, and this I really do want to do a tutorial on this, because this was really fun. But we're actually like grabbing the memory address on RAM, and we're actually like getting it taking the data inside the memory address and actually creating a struct from it. And we're actually like doing like uninitialized memory and actually creating it. Yeah, you can literally see it. I'm like going from I'm telling it what part of this data is actually the memory address for like tile position, stuff like that. So this one's a little bit more advanced, but I might actually go ahead and like do a tutorial on that, because this was fun. Like multi-threaded and RAM address was definitely not what I was expecting to do, but it was an interesting thing. But yeah, so those are some things we're going to be like showcasing. And if anybody has any like requests for tutorials, I already got a list of requests. I'm looking for more requests. But yeah, also, like I said, doing a custom like debugging system, and also like a few things. Do you know some of this like transform stuff? Unity 6.6, you don't need some of this stuff anymore. I need to actually add using like if Unity editor is less than Unity 6.6. 6.6 actually added some stuff that makes it where I no longer have to worry about stuff like that. But yeah. Anyways, so dialog graph, custom graphs, custom multi-threaded and burst compiled physics, using memory pointers and actually grabbing RAM address to multi-thread some stuff inside Unity. Those are some of the tutorials I'll be going over. like I said, my channel's aimed at intermediate to advanced stuff. So burst compiling, multi-threading, and creating like entire graph systems, stuff like that. That's basically what I'm going to be like going over. But yeah. Oh, also we'll be going over transform handle. I really wish this was something like people like heard more about. I'm actually going to just randomly grab something. For anybody that doesn't know what transform handle is, okay, so everyone's used like transform. Like if you're UNT, you've used transform. Well, there's a thing called transform handle, and there's so little devs that heard about it. It's so nice. For anybody wondering, transform handle is a struct value that matches the transform component. But the thing is, since it's a struct, you can burst compile like code with transform handle. Like if you were to try to like send like a transform component into like a, actually, you know what? I think I actually got like a Unity project I was like just screwing around with. Yeah, I do. I'll actually go ahead and like open it just so people can actually see what I'm talking about. Yeah. All right, we're gonna be just so people can see transform handle. We'll be using transform handle, not using transform. So the tutorials, none of them should be using transform. Also, none of the we'll be using physics transform in some areas as well. So yay. Yeah, I'm trying to think what else. I think that's pretty much like a good overview of like the things I want to actually like show off on tutorials and stuff like that. Yeah. If anybody wants to, I can also teach people how to create custom sprite editors. Because I actually do have a custom like sprite editor. So if anybody's wondering how you actually create your own custom sprite editor or tile map editor, I can show how to do that too. So like, yeah, so I got like actual like a sprite data provider and stuff like that I can actually teach people how to make as well. So, but yeah, that's basically a few things that I plan to like teach people about. Okay, so here's a fun thing. So let's actually go here. You know, this is like a little like testing thing. Doesn't look visually impressive, but main thing is let's actually go. I'm actually gonna get out that one. Let's actually go here real quick. Gonna just exit out the Metrovania project. If anybody, okay, so here is a use of transform handles. So we have our transform handle, and then we actually have a native array. And basically, there is a actual, let me grab transform handle manager real quick as well. Yeah, I actually managed to simplify this a lot. So let's actually go to the, we got move struct. Here it is. Okay, so we have a parallel, like a, or no, not parallel, but like a, just a normal iJob for doing like multi-threaded job stuff. And also a look at and move towards. Notice that it's mainly used with burst compiling. And a few other things. So, oh yeah, I updated it where I just need to look at and move local. So, I basically have a struct that just takes in two transform handles and allows me to like choose a thing that's moving and then a target. And actually, you know what? Instead of explaining it, I'm going to just show it. Let's spawn 10,000 enemies. Behold the horror of transform handles. Oh, do you know, my computer is not that strong for what's about to happen. And also, I can make it where there's like 0 garbage allocation. So behold, click play, yep. And now I'm being chased by 10,000 enemies. No frame drops, nothing. Oh, that's actually very disorienting. Yeah, like it takes less than a millisecond to actually spawn 10,000 enemies. Man, that looks disorienting. There's like all just like converging into one. But basically that's why we're going to be using transform handles. Really high performance, really good memory control, stuff like that. And I think starting with Unity 6.3, all game objects, I think actually all mono behaviors also have it, like transform handle. I think transform handle, yeah, okay, yeah. So you can actually, instead of using like transform, you can just say transform handle, and so forth. And if we go in here, you'll see basically transform handle is actually just getting the component off the game object. I'm going to be honest, instead of doing that, you might want to just do game object.transform handle, and oh yeah, T handle. We'll just call it T handle. I got that. But you want to probably like allocate it locally just once, and the reason why is if you go to game object, notice how you're actually having to go into C++ land. Yeah, you're having to marshal. You want to avoid having to repeatedly marshal. So like what you want to do is you just want to, that's why people say you want to catch things like instead of just like getting to transform, like instead of just doing transform and then like blah blah wherever you need it. The reason why you do like something like this is you don't want to do like access transform. You want to actually just say that. The reason why is like okay, if I do this, okay, I don't have to go C++ land. If I go here, if you just say transform, you gotta now go to C++ land, and going from C# to C++, it slows down. Hey, no auto-statics cleanups. That's actually what my first tutorial video is about. I did not know Unity actually added that. Okay, so no joke. I'm actually, my first tutorial that I'm planning on doing is actually about no auto-statics cleanup and statics cleanup. So, hey, that's kind of funny that I just randomly see Unity just have that. But yeah. That's actually, that'll be what the first tutorial should be released tomorrow is about. I actually did not know Unity recently implemented it into their actual like game objects. So cool. But yeah. So you want to catch transform. You don't want to actually just access transform, because every time you access transform, you go to C++ land, you have to marshal it, and marshaling is a huge extra cost CPU wise. So basically, instead of doing like transform, you want to just say, just catch the transform handle. Just use transform handle instead. If you're using a version of Unity, get transform handle once, and then just from there use it. And if anybody's wondering, like, does transform handle have the same thing as like transform? Yes, literally, transform handle has the same methods as like transform. And if you update the transform handle.position, it will automatically update the game object transform position. So like updating game object updates the same thing as like transform. So if you can do it, update transform handle instead of the game object transform. You will like whenever you can. Yeah. So granted, you have to, I think it requires Unity 6.3. If you're not using Unity 6.3, out of luck. But I just want to mention that because that is something that a lot of people don't know is a thing now. And biggest reason is a transform handle is a struct. It can be burst compiled. It actually has like a backend for NTID already, even though it's part of like the game objects. So like if you use transform handle, it makes it easier to bridge later to other stuff. Okay, rant over. I just want to mention that. And now to just like undo all of this crap. Yeah, so that's basically some of the stuff I want to show off. For the rest of the stream, I'm going to be honest, after showing that stuff off, I was going to actually work on like creating some of the tutorials on stream. So you guys actually, it's time to actually learn some new stuff. I was actually gonna be showing off how to use like the auto static cleanup. That's actually what the first tutorial series is supposed to be about. There we go. Yeah. All right. So also talking about second video will be on entering play mode. For anybody that doesn't know, probably should like actually, yeah, you know what? Let's actually show this off real quick. Let's actually grab this. Let's see. I'm gonna grab like a link real quick just to show this off. Okay, here we go. All right, yeah. I'm actually gonna bring this link over to side so I can still see chat. But yeah, so first tutorial series is going to be basically about like auto static cleanup. There's you saw that inside Unity. There's also a no auto static cleanup, which is very useful. Holy crap, this is so much easier than like the stuff they used before. If anybody has used like well here, this is actually good transition. So if anybody's ever used, there's a thing called like a play mode state change. Play mode state change for Unity editor, and you have like your enter play mode, exiting edit mode, play mode, stuff like that. You had to do like this, and then you had to like literally do you had to like actually go through a process and actually do like different actual things. I'm actually gonna just right, interplay mode actually is I whoops, my bad. I was like, wait a second. I was like, I accidentally grabbed the enum. Sorry, there's actually I accidentally grabbed the enum. I was like, wait a second, that's not right. Editor application, sorry, 1 second. Editor application dot play mode state change. I was like, wait a second, that's not right. And then those values I said like there. So if anybody's ever had to use like play mode state change, and it's only editor, it's literally only editor. You don't have to suffer through this anymore. You can actually use like on entering play mode now. This is actually Unity engine attribute, so it's not editor only. So you can actually use this inside of like your builds. Fun fact, basically, if you actually do this inside of your code for builds with Unity versions that support it, it basically runs before the first scene is loaded. So you can actually do, example, the database thing that I was showing off, where you can actually like do database registry. On newer versions of Unity, you don't actually have to set it as a predefined asset, which is very nice. But I'm going to be basically talking about that a little bit. There's also like if anybody's ever done like there's also replacements for this as well. Like if anybody's ever had to do like initialize like on load, you don't have to do this anymore as well. There's actually a replacement for this. Thank you, Unity. So old way, editor only. New way, there's actually a on code initializing now. So you don't actually need to use initialize on load anymore. You can actually just use on code initializing. It's basically the new way, runtime and editor, which is really nice. Do note this actually runs after like restoring like objects, like deserializing them. So basically, like whenever you first load a project, you know, anything that you have saved inside the inspector, when you actually make a build of that, Unity actually keeps track of that in the serialized data. This actually runs whenever like a player actually first opens up the game and actually is like taking data from the build and actually deserializing it, which may sound like something you might not need to do. Oh, trust me, it's really useful, especially for like deserializing save data and a few like other stuff, or like setting up static systems and manager values. Oh, and also for each like initialize, there's also a on code deinitialize, which is really good. Imagine a player hits exit game, or like somehow manages to like crash a game or like something. You might be able to like actually safely like soft exit and like make backup temp data with like on code deinitialize. So we're gonna be talking about that. And there's actually there was no version of this before. You could not do not on code deinitializing. That's actually like the serialization and managed code during like a code load. I meant on code unloading, stuff like that. What about that? Oh no, actually you could just use on exit play mode. Sorry. Yeah, actually this would probably be better. I just realized this might actually be a better alternative for that, because I just realized on code initializing actually now loads whenever like our on code unloaded actually runs before code is unloaded for a code reload. I actually don't know if there's actually a assembly reload events. Yeah, there was a thing called like assembly reload events dot before assembly reload that replaces. So, anyways, so I'm gonna be just making some examples. Show how this works, just in case anybody actually sees this before going into my actual like actual like code and stuff. No. I am wondering. It says my kilobytes is like very short. One second, I want to see my I don't know if anybody like is getting like lag inside YouTube, but it shows that I'm only like sending a certain amount of like a very small amount of kilobytes, like just enough for like audio. Oh, it's probably because I haven't like moved anything on screen, so it's actually catching it. But never mind, that works. But yeah, so if anybody's ever had it where they have like static variables and they don't want to have to deal with like domain reload and so forth. So like if I actually go to project settings and go to editor, you have this options for like do not reload domain or scene. Whenever you have this option set up, Unity normally does not reset static variables. Well, that can cause some headaches and bugs whenever you're debugging, because you might have forgotten, hey, I need to reset this static variable. Well, Unity added a couple new attributes that actually will help set that up. Auto statics cleanup and a few other things. There's also like a no auto statics cleanup, and basically like an example of like why you might need like the no auto statics cleanup. And do note these are mainly for entering play mode. They're not meant for like so like when you're first entering play mode and so forth. You can actually use that to prevent like values from being reset, or make sure values are reset if you have like domain reload turned off and everything. But if anybody's wondering why you might need like specifically to know auto statics cleanup one, sometimes your static values are reset whenever you are actually just like saving. So like no domain reload is whenever you are entering play mode, it doesn't do like a domain reload, but whenever you save a file inside assembly and the code recompiles, there is still a domain reload, even if this option is actually like turned off. I love how it goes into a different screen. So even if you have like do not reload domain or scene, if you recompile a script and that assembly had static values, it'll still go through the domain reload and stuff. So you might need this to actually prevent like that domain reload from actually like initial like resetting variables and stuff. And if anybody's wondering like how do you tell like what value the auto stack cleanup actually forces it to be, you can do initial value. So if I actually say like 5, so let's actually do this. I'll actually do like 5 here. So I made it where every time I click during play mode, it will update the static value. And then whenever you exit play mode, it will automatically like reset one of them, but not the other. So I'm going to click here. So both of these values, the entering play mode value for one counter is 0, the other one is 5. I'm going to actually click it real quick. I'm going to exit. When I enter again, you'll see that, wait, let me make sure that I should actually, oh, right, yeah. For a second, I thought I accidentally had that set up where the, oh, right, it was not clicking. I was like, wait a second, that should be updating. It was any key on the keyboard. Okay, sorry. I forgot what I wrote. Okay, yeah, so now it says 112. So I literally can see 112, but you'll see this one is 5. That's because like the auto stack cleanup automatically sets it to whatever the initializer value is. So if I have this like, I can actually manually tell it, hey, every time I enter play mode, set it to this value, which is very useful for preventing bugs. Really useful for preventing bugs. I mean, really useful because you might forget to clean up static variables like static systems or manager classes, stuff like that. There's a whole lot of things you can actually use this for. But yeah, that's basically, I think I've gone on long enough, like talking about what I'm planning to do. So a couple of things I need to actually like, you know, like let's see if I can actually let's go to I'm opening something up on left monitor real quick. Any way to actually like close this one? Oh, well, I was gonna see if I can actually, yeah, there we go. Okay. So I'm currently like working on actual like resource website. So like actually making like a documentation website. Early work in progress. Very early work in progress. I need to update some of these things because some of this stuff was actually like like before I started working on this or like actually working on YouTube channel, but I do got a little site I'm going to start like uploading everything to. I gotta add so much more to it, but once I get a few tutorials done, I'll make the documentation website public so people can literally just read the blogs, and I'll have like the like how to create a dialogue system on there. So I'll have a video format for tutorials, and I'll also have like a blog, and the blog will have a copy of the code. So if you're like going for a tutorial and you're trying to like figure out like, okay, how do you like the code in this step? What am I missing? If you're like running into an issue, you could just copy the code from the dev blog and so forth. But yeah, that's basically, I just want to do a small stream just showing off what we'll be doing. I'll do the database registry first, and or like for like a series. So like database registry will be the first series. For the first actual video, I'll actually be showing how to do like auto static cleanup stuff inside Unity, and also like mentioning like on entering play mode. And then I'll be having people like give feedback on the multi-threaded physics system, because I think the multi-threaded physics will be like a huge well, I know it's going to be a huge video series. Like it's going to be so many. I plan to teach people how to recreate different game mechanics, like the digging and Ori and the Will-O-Wisp. For anybody that hasn't played, there's like sections where you can actually like dig through the terrain and stuff, like a Metroidvania ability. I'll be actually teaching people how to use that. If anybody's wondering, like just for reference, like how we're going to be doing that, there's API called Geometry Islands, and basically we're going to be using that for a few things. I love how if you actually like search geometry islands, I was actually going to go to like the I was going to actually go to like the documentation just showed us off. Okay, yeah, so I'm going to be showing people how to do like physics composer. By the way, physics composer, you can create destructible terrain. Like this is built-in thing into Unity. You can use it to be create like destructible terrain inside Unity 2D. If anybody's ever seen like the Worms games, yeah, you can actually just create like a destructible terrain with the physics composer. Basically, like inside the physics composer, you can do a couple different things. There's also a built-in like fragmentation thing. So I think it's like not reset. Destructor, yeah, there it is, physics destructor. Yeah, so if anybody's ever wondering, Unity has built-in fragmentation and slice for 2D, so you could do like destructible sprites, destructible terrain, stuff like that. That's actually just built into Unity, and you can even burst compile and multi-thread it. I'll be showing how to do that as well, because I know that can be a little bit like daunting trying to figure out how to do like destructible terrain. But yeah, man, I'm trying to think what else should there's a lot of things I will have to go through. Oh, I just realized, I was like, why is there no version like Unity 6.5? Unity 6.5, by the way, renamed the low-level physics 2D to physics core, so you probably have to type in like physics core 2D instead of low-level physics. Yeah, there we go. So if anybody's like going for documentation, they can't find physics core 2D in like older, like Unity 6.3 or 6.4. It was originally called low-level 2D physics. It's now renamed to physics core 2D. But yeah, so just heads up. And we're going to be using this for a lot of the creating a custom physics system for like multi-threading. I'm thinking one-way platforms, destructible terrain, how to create like a Metroidvania controller, Legend of Zelda top-down controller, how to create custom physics components. Again, like the custom like tile map, like this is not this project again has no colliders, no rigid bodies. There's 0 rigid bodies colliders. They're all my custom physics components that I just call like SF shape components that has like a burst compile and multi-threading support. The tutorial series will have a lot of that. And don't worry, it sounds daunting. The main thing is just getting the like the base class. If you get a good base class for them, it's a lot simpler, because like a good base class can do like a lot of stuff. Like for example, if I actually just go to like after the base class, creating like a SF rectangle, so like would be equivalent of the box collider 2D, but with burst compile support, it's literally 66 lines of code. Once you have like a decent base class. So when we're doing the tutorial series, getting through the base class is like the main thing. I think the base class is only like 600. Yeah, so like for 600 lines of code, you can make like a base custom physics component that supports like burst compiling and a few other like odd jobs for like parallel multi-threading. And then you can just go your own way and just like create your own custom things. Literally circle shape with after like inheriting from base class is only 38 lines of code. So custom physics components are actually not that bad once you start understanding it. It's just the idea of like figuring like actually like learning it from very like beginning. The only one that might be a little rough is the custom like tile map shape, because basically create like the custom tile map shape, we actually have to get the physics from each tile that's on a tile map renderer. If you're using 6.4 and newer, it's a lot easier in 6.4 and newer, because you have the position array and then tile array. These are new things added in 6.4. So if you're using like 6.4, you could just use the tile maps like a position array. You can also use like the sprite array enumerator too. It makes things a lot simpler. to create your own custom like tile map. Basically, how this works is just run down. You get all the tiles inside the tile map, and basically you create a composer. Composer is kind of, if anybody's ever like used like the composite collider. Composer is basically a low-level version of the composite collider, so you can actually like fuse multiple like custom physics shapes together, and you can even use like a Delaney pixelation and stuff like that for like the calculation of it. No joke, how to create like a custom tile map collider with burst compiled and multi-frame support. You just create a like a vertex list using like native list. You get every tile position on the tile map, and you just grab every tile data with the tile positions, and this is just a simple like a method I passed it or like created. It basically just grabs the used tile data and returns it in a actual like a out statement. And basically you just, for every single tile that's actually used inside tile map, you just grab its sprite. Each sprite actually has there's actually a built-in method Unity that tells you the amount of sprite shape counts in that tile. And the reason why that's a thing, let's actually go here. Let's go to, so let's just randomly grab like, hey you, let's actually grab you. Yeah, we're gonna have fun with you. We're gonna violate our friend here. If you actually go to the sprite editor, custom physics shape, you can actually generate a custom physics shape, and you can actually split his physics into 2 different shapes. So, and both physics shapes will be on the same sprite. So that's why like you gotta check to see to get the physics shape count. And the reason why you need that, why you might have that is you might have like really unique shape sprites or something that you are actually like splitting the shape into 2 different ones. Basically, once you get the sprite or the sprite for the tile and figure out how many physics shapes it has in it, you basically iterate over each physics shape by getting the tile's physics shape. And then once you have each physics shape, you actually calculate the position of each vertex. So like, let me grab like actual, like something that's a little bit, oh, I know, perfect thing to use for this environment. Let's go to my, yeah, let's actually, yeah, that works. Where is it? You know what, we'll just use this. It's a guy. So like, basically, each one of these white boxes is actually a vertex. Yes, that is actually a vertex inside the sprite editor. So each one of these vertexes, or each one of these dots represents a vertex. On a vertex path, you just take those white dots, calculate the position through a matrix, and you basically, by doing this, you actually get like the actual vertex positions based on that sprite's position inside like a sprite sheet. And all you got to do for that vertex is just add the tile position. That's why we got like the tile positions earlier. And don't forget to add like the tile anchor, because you can actually like change the tile map anchor. And by doing that, you actually get the world position per vertex of that sprite that's used in that tile. And no joke, you just add those 2 native lists, just create a physics transform, set the add like an offset to the position. And the reason why I say offset, if we actually go to like a custom thing, you'll notice that there's actually like a offset you can actually add to it. So let's actually grab the one that we're actually looking at. So you can actually add like a little offset to stuff like that. So that's what that offset is. And you just tell the composer that you're adding a new layer, and the layer is literally just created from the list of vertex paths made from the sprites. And you basically clear it, the vertex path. If you're using the using statement, you don't have to worry about like manually disposing it, and make sure it's like a temporary allocator. Destroy the composer, that way you don't have a memory leak. If you forget to destroy it, you will have a memory leak, just heads up. I learned that the hard way the first time I did this, or I was teaching myself this, and that's literally it. Like, once you do that, before you destroy the composer, you just tell it to create a polygon geometry, and it will take all the vertices you added from all the sprites, and it will create this outline. So this is like this white outline here is actually the result of the sprites from this one tile map being added, and it just creates a polygon shape. And if they're like separated shapes, so this one's right here, so like this so this like bottom left L is one shape, this top right one is second shape. It grabs all the island geometries and basically just adds it into the physics body. Okay, that sounds like a lot, but once you dive into like when I start making tutorial, it's actually not that bad. It's actually super simple once you actually knew it. Do note, just a warning, I do have one bug in my code. It's not okay. It's not a like a coding bug. It's a logic bug. So fun fact, if I actually damn, I'm opening a lot of like different little projects to show this off. Okay, this is like the 4th project we're opening for demonstrating stuff. Yay! Okay, so I can actually demonstrate this little logical error very quickly. I need to do a matrix multiplication for rotated tiles. If I actually go inside the scenes, dungeons, let's go here. Get in here, and let me actually turn on the physics debugger so you guys can actually see it. There we go. You notice here, notice how there's a white box here for the collision. So I gotta to fix bug, I gotta make it where it also takes into account of the tile rotation, because I forgot to do that. That way it rotates like the actual sprite. So if I actually like go here, if I actually like open this tile map, let's actually do this. Let's actually do bench palette. Yeah, here. So if you notice, so it looks right here. So correct, looks correct. All right, well, let's rotate it. That's weird. Maybe a little hard to see on stream, but the physics shape created is the same as this one. So if you actually are rotating tiles, yeah, you gotta actually like do a matrix scaling to update that. I just gotta do that, and then like the tile map should work perfect. I completely forgot about that when I was doing the tile or like creating the tile map thing. But simple fix. Okay. So I was just wanting to go over like what I plan to be doing for the tutorials for the first couple of weeks of the channel. That's basically it. I'm gonna call it. I just want to do a small stream and actually show what I plan to be doing. So thank you all for whoever joined. Hope you guys look forward to like the tutorial series. Like I said, most of them are going to be intermediate to advanced, not too advanced at the very start. Yeah, I don't plan to do like really hard. I'm going to avoid the custom entity ID tile thing where we actually are going into RAM address. I'll avoid that for the like the start of the series, but I do want to do that because that was actually a fun thing. But yeah, I'm gonna call the stream. Thank you all for joining. I just want to show do a stream showing what I'm planning to be doing for the actual like first few weeks of channel. Hope you guys enjoy. If anybody has any more things they want to see, yeah, I can actually I'll take requests. So far I got like RSUV shaders, graph toolkit, dialog system, database registry, a lot of low level physics stuff, and a few shader things with shader reflection API. So yeah, we're gonna that's pretty much that's gonna be our first few weeks of like the channel for actual tutorials and not just streams. So I'm gonna call it. Thank you all for joining. Hopefully you guys have a wonderful day, and the first video should go up tomorrow uh, afternoon my time. It's like 2:25 p.m. Right now for me. For video watchers, that probably doesn't mean crap for them. I just realized that, but it'll be up probably like 4 p.m. Like Central Time. I guess we'll say. Yeah, we'll say like before then. But I'm ending stream now. You guys have a wonderful day. Thank you for joining, and take it easy.